So we're going to have a little look at the hole feature in Creo, and the hole icon for the hole tool is located here in the engineering subsection, and if we select that and we have some geometry in our part, which as you can see I've already created, what this feature needs to begin with is it needs a surface within the part to begin this hole feature on. So we're going to select this top face for this first example, and as soon as we click on the top face we get a preview of a hole. Obviously this hole has a depth, a diameter, but what it doesn't have currently is any way to lock down its position on this top face. So obviously it's free to move anywhere. So if we want to lock its position down on the face, what we can do is we can drag these little green drag handles here, and what they want to do is they want to snap to some geometry that it can use as a reference for its position on the face. So let's snap one of these to this side face of the part, and instantly you can see that it enters a dimension there. If we want to change that dimension, we can double click on it and then enter a value of our choosing, and then we're going to do the same but in a vertical sense using this other drag handle. So maybe we'd want to reference this bottom face, and you can see there that it's entered the value that the hole currently is at. But again, if we wanted to enter something specific in there, we could, and there you go, we've locked down the position of the hole. So if we were to OK that, you can see that we happen to have a hole that passes all the way through the part. Its position is locked down. It's referencing the outside faces of this block, so if the outside faces of the block were to change, the hole would change accordingly. So let's look at some of the other options that we have in there. So if we go back into the hole feature by right clicking and going to edit definition, then we could change the depth so that it doesn't go all the way through this part. So as you can see, I've reduced the depth there and it's not breaking through the bottom surface of the part anymore. The hole stops at whatever depth I've entered into the entry box there. So 47.2 currently. Again, I could any of these values I can change just by double clicking. I can change the diameter of the hole there as well. But let's say however thick this part gets, I'd like the hole to go all the way through it. So we can change our value entry box there to intersect with all surfaces in the part, and then no matter how thick the part is, the hole will always pass all the way through. But let's change that back to a entered value now. And some of the other options in here, if we OK the hole there and then change our display style up here to a wireframe display, you can see that the bottom of that hole is currently flat. So if you were to manufacture this, you would have to maybe use a slot drill, at least to finish the bottom of that hole, or maybe a U-drill. But you couldn't use a regular angled engineering drill, because you'd end up with an angled bottom to the hole, and that's not what we've got there. But let's say you did want a hole which represented a drilled hole with a standard drill with, say, an angle of 118 on the end. Well, we can select this option here, and whereas currently we're using this, use predefined rectangle as drill hole profile, this changes it to use standard hole profile as drill profile. So if we change to that, the icon's quite self-explanatory, and then we click on OK, you can see that we've got a more realistic lower portion of the hole there. So it's as if a standard drill with a 118 degree angle has come in and drilled this hole, and it's the inverse shape of the end of the drill that you're left with there. So that's a slightly more realistic type of hole. Other options in the hole wizard here, if we just change our display method back to shaded, we can specify a tapped hole using a standard type of thread. In this case we're going to choose a metric thread. So the way that we do that is we switch from this simple hole type to a standard hole type, which again, the icons are quite self-explanatory. This one has a threaded fixin shown in the hole, whereas this one just has a plain sided hole with no threads. So let's select the standard hole type. You can select the sort of standard that you need in the next box here. So you can have UNF threads, ISO threads, or UNC threads. In this case we're going to pick metric ISO, and then let's pick an M8. No, let's pick an M10 hole size. So you can see that it has that standard already stored in the system. It has all the ISO metric standards, all the coarse and fine thread standards, and the majority of the superfine thread standards. And what it will do is it will remove material from your part corresponding to the diameter of the drilled hole size before you tap it out to the metric size. So in this case that would be a 8.5 drill that you would drill the hole with, and then you would get an M10 tap, and then you would run the tap down into the hole. So let's OK that feature and just have a little look at that. So you can see that automatically Creo attaches a hole call out note to the hole, just detailing what the hole is, what size it's been tapped to, its depth. So you can see that the depth of the tap and the depth of the drilled hole that before the tap has been sent down it is detailed here. And all this data can then be sent to the drawing if you have to create a drawing of this part. It's all stored within the part, so it's easy to pull that information through to a drawing. And then if we hover over the feature, we get a little skeleton preview of the hole itself, and you can see that there's a representation now of the threaded portion of the hole. You can see that as the slightly larger cylinder that finishes before the bottom of the hole. And if we look at this part side on, you can probably get a better appreciation of that. You can see that there's this cylindrical portion here that's slightly larger. That would correspond to the threaded portion of the hole, and then within that there's the portion that's been drilled before the tap has been sent down into the hole. So all these are contained within the hole wizard. All the sizes are already in there. All you have to decide is where you would like the hole positioned, so these horizontal and vertical references, and how deep you would like the hole to go. But if you want a little bit more control over some of the parameters that are driving this, if you click on shape here, you can see that the 8.5 has been locked out because that's obviously related to our thread standard that we've selected. It's an 8.5 drill that goes down this hole before the tap does. The depth we can still change. We can enter a value in there and it will change in here. So I just changed the threaded portion of the hole value and it automatically increased the drilled portion of the hole. We can change the end angle of the drill. So say we needed a 90-degree angle on the end of the drilled hole, we could do that. You can see that's changed accordingly on the model. Or we could countersink or counterbore this hole as well. So we have countersink options here. You can see it's added a countersink, maybe for a countersink screw or bolt, some clearance for that. And if we need to change the size of the countersink, we can go into shape again, You can see that the countersink is shown up in here. The angle between the faces of the countersink we can change, and the outside diameter we can also change as well. So let's increase that, and you can see it increase in the preview as well. We can also counterbore the top of this hole if we need to counterbore to allow for the head of a fix-in. So we've got all those options. You can even mix countersink with counterbore, and if we OK that, you can see the effect that that has. So there's lots of predefined standard holes in there, and lots of help with being able to create just standard plain cylindrical holes as well. So that's the hole tool.